Now we will study the first chapter of 10th standard geometry and its name is Similarity. Previously you have studied similar triangles and congruent triangles. Now we will revise it. Let us see what the congruent triangles are. In triangle ABC and in triangle PQR, the one correspondence is A to P, B to Q and C to R. Angle A is congruent with angle P, angle B is congruent with angle Q and angle C is congruent with angle R, and side AB is congruent with side PQ, side BC is congruent with side QR and side AC is congruent with side PR. So we can say that triangle ABC is congruent with triangle PQR. Here we have already seen the one correspondence, that is ABC to PQR. Now let us study similar triangles. In triangle DEF and in triangle LMN, angle D is congruent with angle L, angle E is congruent with angle M and angle F is congruent with angle N, as well as ratio of their sides DE to LM is equal to EF to MN is equal to DF to LM is equal to 2:1. So we can say that triangle DEF is similar with triangle LMN and one-to-one correspondence is DEF to LMN. Now second point, similar triangles are not always congruent triangles. That means if I will keep triangle LMN on triangle DEF, they will not match exactly. But here congruent triangles are always similar triangles. If I will keep this triangle PQR on triangle ABC, they will match exactly. These two triangles are congruent triangles as well as similar triangles, but these two triangles are similar triangles but not congruent triangles. Let's study ratio of areas of two triangles. Here triangle ABC and triangle PQR are drawn. In triangle ABC, BC is the base and AM is the height. In case of triangle PQR, QR is the base and PN is the height. So we know the formula that area of a triangle is equal to 1/2 base into height. Now area of triangle ABC is equal to 1/2, base is BC and height is AM, so 1/2 into BC into AM upon area of triangle PQR is equal to 1/2 QR into PN. After simplifying it, we get area of triangle ABC upon area of triangle PQR is equal to BC into AM divided by QR into PN. That means the ratio of the areas of two triangles is equal to the ratio of the product of their bases and corresponding heights. Now here bases and heights of two triangles are different. If the height of the two triangles is same, let us see what happens in triangle DEM and in triangle DFM. Vertex D is common, that means their height is same, but their base is different. So area of triangle DEM divided by area of triangle DFM is equal to EM upon FM. That means ratio of areas of two triangles having equal heights is equal to the ratio of their corresponding bases. These are the corresponding bases. Suppose bases of the two triangles are equal. Now in this diagram, in triangle LMN, MN is the base, LP is the height. In triangle XYZ, YZ is the base, XQ is the height, and length of MN is equal to length of YZ, means MN is equal to YZ. Then area of triangle LMN upon area of triangle XYZ is equal to LP upon XQ. That means we have considered here their corresponding heights. So the ratio of areas of two triangles having equal bases, these bases are equal, is equal to the ratio of their corresponding heights. Now students, if heights and bases of two triangles are same, then what will be the ratio of their areas? In this case, height and base are same, so ratio of their areas is equal to 1:1. Students, let us solve some examples. In example 1, triangle ABC and triangle PQR are given. In triangle ABC, BC is the base and AM is the height. Length of the base is 8 and length of the height is 6. In triangle PQR, QR is the base, PN is the height. Length of QR is equal to 6 and length of PN is equal to 3. And we have to calculate area of triangle ABC upon area of triangle PQR. Let us see how to solve it. As we have seen previously, areas of two triangles are proportional to the product of their bases and respective heights. In case of triangle ABC and triangle PQR, the ratios is equal to BC into AM divided by QR into PN, and substituting the values of BC, AM, QR and PN, we get area of triangle ABC upon area of triangle PQR is equal to 8 into 6 divided by 6 into 3, and after simplifying this we get 8 upon 3. That means ratios of areas of these two triangles is 8:3. Let us go for example 2. Here in the figure, triangle ABC and triangle ADB are given. In triangle ABC, length of BC is 4 and in triangle ADB, length of AD is 8, and we have to find out the ratios of areas of triangle ABC and triangle ADB. Now, triangle ABC and ADB have common base AB and their height is different. So, ratios of areas of triangle ABC to triangle ADB is equal to BC upon AD. That means it depends on their respective heights. So, substituting the values of BC and AD, we get 4 upon 8, and after simplifying we get 1 upon 2. That means ratios of areas of triangle ABC to triangle ADB is 1:2. Let us study basic proportionality theorem. If a line parallel to a side of a triangle intersect the other sides in two distinct points, then the line divides those sides in the same ratio. In triangle ABC, segment DE intersect this triangle in point D and E, and segment DE is parallel to side BC. Then we get AD upon DB is equal to AE upon EC. Let us solve one example based on it. In triangle PQR, segment MN parallel to side QR. PM is 2, MQ is 4. PN is 3, NR is X. So we have to find out the length of NR, that means we have to find out the value of X. In triangle PQR, segment MN parallel to side QR. It is given. So by basic proportionality theorem, PM upon MQ is equal to PN upon NR. Substituting values we get 2 upon 4 is equal to 3 upon X. Therefore X is equal to 4 into 3 upon 2 is equal to 12 upon 2 is equal to 6. So value of NR is 6. Let us study the converse of basic proportionality theorem. If a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. Now, in triangle PQR, PD upon dq is equal to pe upon er. Then segment de is parallel to side qr. Let us solve one example based on it. In triangle ABC, ax is equal to 3, xb is equal to 6, ay is equal to 4 and yc is equal to 8. Now ax upon xb, value of ax is 3, xb is 6, 3 upon 6 is 1 upon 2. Similarly, ay upon yc is equal to 4 upon 8. After simplifying we get 1 upon 2. So ax upon xb is equal to ay upon yc. So we can say that by the converse of basic proportionality theorem, segment xy parallel to side BC. Here is xy, here is BC. Both are parallel to each other. Let us study theorem of an angle bisector of a triangle. The bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. In triangle PQR, segment QT bisects angle Q, then we get PQ upon QR is equal to PT upon TR. PQ upon QR is equal to PT upon TR. Let us solve one example based on it. In triangle MNP, segment QN bisects angle N and MN is 5, PN is 7, MQ is 2.5 and we have to find out the length of QP. In triangle NMP, by the theorem of angle bisector of a triangle, MN upon NP is equal to MQ upon QP. So after substituting the values we get 5 upon 7 is equal to 2.5 upon QP. Therefore QP is equal to 7 into 2.5 upon 5, and after simplifying it we get value of QP is equal to 3.5. QP is here, whose value is 3.5. Now let us study one property, that is property of three parallel lines and their transversals. The ratio of the intercept made on a transversal by three parallel lines is equal to the ratio of the corresponding intercept made on any other transversals by the same parallel line. Now in the diagram, line P parallel to line Q parallel to line R, line L and line M are transversals. Then we get AB upon BC is equal to DE upon EF. These are the intercept made on transversals by three parallel lines. Let us solve one example based on it. In the figure, line P, line Q and line R parallel to each other. Line L and line M are the transversals. Line L made the intercept AB and BC. Line M made the intercept DE and EF. Here length of AB is 3, length of BC is 6, length of DE is 5 and length of EF is x, and we have to find the value of x. Let us solve. By the property of three parallel lines and their transversals, we get AB upon BC is equal to DE upon EF. After substituting the values we get 3 upon 6 is equal to 5 upon x. Therefore x is equal to 6 into 5 upon 3 is equal to 30 upon 3 is equal to 10. Length of intercept EF is 10. Now let us study similar triangles. In triangle ABC and in triangle PQR, it is shown that angle A is congruent with angle P, angle B is congruent with angle Q, and angle C is congruent with angle R, and AB upon PQ is equal to BC upon QR is equal to AC upon PR. Then we can say that triangle ABC is similar with triangle PQR. Here corresponding angles are congruent and corresponding sides are in proportion. Now let us study test for similarity of two triangles. The first test is AAA test, means angle test. Now two triangles are drawn, triangle ABC and triangle PQR. In triangle ABC, measure of angle A is 70, angle B is 60 and measure of angle C is 50. In triangle PQR, measure of angle P is 70, measure of angle Q is 60, measure of angle R is 50. So, in triangle ABC and PQR, for the correspondence ABC to PQR, A is congruent with P, B is congruent with Q and C is congruent with R, then triangle ABC similar with triangle PQR. Since the sum of measures of three angles of a triangle is 180, if two pairs of corresponding angles of two triangles are congruent, then the third pair is also congruent. Hence, AAA test, that means angle test, can be expressed in simple form called AA test, means angle test. If two angles of one triangle are congruent to the corresponding two angles of another triangle under a given one-to-one correspondence between the vertices of two triangles, then the triangles are similar. Let us study second test for similarity, that is SAS test for similarity, and its long form is side angle side test. Now in triangle ABC, length of side AB is 2, measure of angle B is 120 and length of side BC is 3. In triangle DEF, length of side DE is 4, measure of angle E is 120 and length of side EF is 6. Now comparing these two triangles, in triangle ABC and triangle DEF, for the correspondence ABC to DEF, ABC to DEF, AB upon DE is equal to BC upon EF and angle B is congruent with angle E, then triangle ABC is similar with triangle DEF by SAS test for similarity. So we can say that if two sides of one triangle are proportional to the corresponding sides of the other triangle and the angle included by them are congruent for a given one-to-one correspondence between the vertices of the two triangles, then the two triangles are similar. So here triangle ABC and triangle DEF are similar by side angle side test. Study the last test for similarity, that is SSS test, whose long form is side test. In triangle ABC and in triangle DEF, the length of the side AB is 6, BC is 8, AC is 10. In triangle DEF, length of side DE is 3, EF is 4 and DF is 5. So in triangle ABC and in triangle DEF, for the correspondence ABC to DEF, AB upon DE is equal to 6 upon 3 is equal to 2 upon 1. BC upon EF is equal to 8 upon 4 is equal to 2 upon 1. AC upon DF is equal to 10 upon 5 is equal to 2 upon 1. That means AB upon DE is equal to BC upon EF is equal to AC upon DF. Then triangle ABC similar with triangle DEF. If three sides of one triangle are proportional to the three corresponding sides of other triangle under a given one-to-one correspondence between the vertices of two triangles, then the two triangles are similar. Here triangle ABC and triangle DEF are similar by SSS test for similarity. Let us study some examples. In this example, in triangle ABC, measure of angle B is 75. In triangle EDC, measure of angle D is 75. And the question is, in the figure, state which two triangles are similar by which test. Now in triangle ABC and in triangle EDC, for the correspondence ABC to EDC, this one correspondence is important. Angle ABC congruent with angle EDC. Reason is 75 degree each, 75. Angle C is congruent with angle C. It is a common angle for both the triangles. So we can say that triangle ABC similar with triangle EDC by a test for similarity. Second example, are the triangles in the following figure similar? If yes, by which test? So in triangle PQR, PQ is 6, QR is 8, PR is 10. In triangle LMN, LM is 3, MN is 4, LN is 5. So in triangle PQR and triangle LMN, PQ upon LM is equal to 6 upon 3. After simplifying we get 2 upon 1. QR upon MN is equal to 8 upon 4. After simplifying we get 2 upon 1. And PR upon LN is equal to 10 upon 5 is equal to 2 upon 1. So from this we can say that PQ upon LM is equal to QR upon MN is equal to PR upon MN. Means corresponding sides are in proportion. So triangle PQR similar with triangle LMN by SSS test for similarity. Let us study theorem of areas of similar triangles. In figure, triangle PQR and triangle LMN are shown. These two triangles, triangle PQR and triangle LMN, are similar with each other. Then area of triangle PQR upon area of triangle LMN is equal to PQ square upon LM square is equal to QR square upon MN square is equal to PR square upon LN square. The ratio of the areas of two similar triangles is equal to the ratio of the squares of the corresponding sides. Let us solve one example based on it. Area of triangle PQR is 80. Area of triangle LMN is 125. Triangle PQR similar with triangle LMN, and we have to find out the ratio of side PQ to LM. By theorem of areas of similar triangles, area of triangle PQR upon area of triangle LMN is equal to PQ square upon LM square. Now area of triangle PQR is 80, area of triangle LMN is 125. After substituting the values we get 80 upon 125 is equal to PQ square upon LM square. After simplifying we get 16 upon 25 is equal to PQ square upon LM square. After taking square root from both the sides we get PQ upon LM is equal to 4 upon 5.